Hello, in this episode, we'll introduce PyTorch in Google Colab. So here's a code that I prepared. So we have Keras. Why do we use PyTorch? So PyTorch gives more flexibility in terms of accessing gradients in the neural network. And also it makes it easier to have custom-made loss function. It is possible in Keras, but sometimes it may be more intuitive and straightforward to do it in PyTorch. So a lot of researchers who develop new deep learning algorithms use this PyTorch language instead of Keras. Keras, the biggest merit is it's very simple to code, fewer lines of code. So when you are actually using a already well-developed algorithm that are readily available in Keras, then Keras is probably better. But for the ones that you need some more customized algorithms, then PyTorch tends to be better. So here we see how PyTorch works. So installing in Google Colab is very easy. Just import Torch, that's all. Right? And then you can use just Python variable like PyTorch. So for example, here, p equals 3.14, that's the pi. And then let's compute our area of the circle. Pi r squared is r is 3, p r squared is a. So you can just use PyTorch like a normal, you would use like a calculator. But what the real power of PyTorch is that it has tensors. So for example, here, x equal torch tensor 3.0. It's like x equals 3, like r equals 3, but it is defined in a tensor. And what does a tensor do? We'll see in the future. And you can use like mix the Python variable p with the tensor x, so px squared, which is y, is also area of a circle, so 28. So why do we use tensor? Because tensors allow you to compute gradient. Okay? So for example, here, x equal torch tensor and requires gradient true. So we allow to compute the gradient with respect to x. Okay? So how do we use it? For example, if we have a formula, y equal px squared and x being the tensor, so we print the y, it's of course the area of the circle, 28.26. The way we compute gradient is y, this y with respect to x. What's the derivative of y with respect to x? What we do is that we actually can just calculate it by just typing the y variable and backward, does the back propagation. So it computes all the gradients, but it doesn't show. So for a particular x, how do we get that? So the y derivative at x, the x gradient, is shown here. Okay, so this is the gradient of x. Okay, so 3.2414 times 2 times at x equal, what do we put x? X equals 3, isn't it? At x equals 3 is 18, isn't it? I think 3. A little bit more complex network. So it's not just one y equals something x, but you can do it more complicated. So for example, a chain like y equal 2x squared and then z equals 3y plus 1, like this. And we want to compute the derivative with respect to x for the z. Okay? So z is a function of y, which is a function of x. So it does that. Okay? If we want to compute the derivative, then z backward, and then where do we want to compute it? At x, isn't it? For the x. And then it computes here the derivative. You can give more complex networks like a neural network and all this. For example, here x and y's are expressed in terms of a and b's. Okay? And then the z is expressed in terms of x and y. Okay? So how do we do that? So we have a torch tensor of a and b. We want to get the gradients here. The x is a function of a and b, y is a function of a and b, and z is a function of x and y. The gradient of z at b, so dz db, well, gets to minus 12. Is it correct? Sure. See, dxdb is 4 times 2. See, y 4 times, and then dx, okay, dz dx, and then dx db. So dz dx, it's 4, and then dx db is 2, so 4 times 2. And then dz dy, which is minus 2, and then dy db, which is 10b. Okay? And if you put the b in here, what was b? It was 1. So you get 8 minus 20, which is minus 12, which is here the answer, which checks out. Okay. So the PyTorch, as you can see, is very convenient for computing derivatives, and you can do it for complex neural network like a deep learning network and get the gradients everywhere. And you can use that gradient in your customized loss function and many things, which is what makes PyTorch really useful. Thank you for watching this episode.